right. Hello. Welcome back. We're doing research summaries number 3. This will be our last day of research summaries. I've got practice packet. We're going to do 2 of these 3. Homework, group work. You're going to do all 3 of those. So let's jump into it. Again, these are combinations of reading and graphs, so and tables. So you need to be able to use both comfortably. Put the 2 together. Go ahead and open up. We're looking at some goofy looking strips of paper, some goofiness, and I apologize if this one doesn't transfer well over the document camera. There are some like really lightly shaded circles you got to be able to see on this one. So I'll go ahead and jump right into it. Number 20, what was the purpose of the battery shown in figure 1? Well, what do batteries do? Oh, nice. I know that a battery hopefully applies an electric field. Hopefully you know what batteries do. Yes? You know about these? What do they do? The electric fields. They have a voltage and that generates an electric field. Number 21. Suppose that in trial 8, the left end of the paper strip had been negative and the right end had been positive. The results would look like what? Well, okay, so here's trial 8. What if we flipped it? We'll just like literally mirror it. If you mirrored this across, what would this look like? Well, there's a space here, and then these 3 are pretty tight. If you mirrored it across, there's a space here, and then these 3 are pretty tight. It's just like literally reflect the picture. Just take this picture, flip it over, and you got B. It's literally just a switcheroo there. Number 24, based on the results of experiment 1, the PI of leucine is approximately what? Okay, so I go back to experiment 1, and okay, in each of the 5 trials we did some stuff on leucine. The greater the difference between the pH and leucine's PI, the farther it traveled. Oh, well, it started in the middle. So which one am I'm just looking for the one that hits the target. Looks like it hits the target there. If you just said, which one looks right? Say 6. Great. pH 6.0, answer there, H. Number 23, which of the following statements best explains the results shown in figure 3 for trial 9? The amino acid mixture contained 2 amino acids at a solution pH of. Okay. Figure 3, trial 9. Okay, I got a circle in the middle. 1 went right, 1 went left. Okay, so I'm looking at this and I'm thinking, okay, trial 9, figure 3, that's pH of 9.5. I don't know anything, but I can cross out the 5 options. Does one have positive and one have negative, or are both negative? Looks like one's positive and one's negative. I don't know what's going on here, but I can eliminate options that don't look plausible. Number 24 in trial 8. The amino acid that traveled the farthest was. Oh, how do I know? Trial 8, the amino acid. Okay, how do I know? All right, so I've got the pH of 3 amino acids was determined. All right, in each of the 4 trials. All right, but what the heck? The amino acid that traveled the farthest. All right, in each of the 4 trials, paper electrophoresis was formed on a mixture of 2 or more of the amino acids using a solution of known pH. The distance traveled, the distance traveled by amino acid depended only on the difference between the pH and the PI. The greater the difference, the further it traveled. Okay. So trial 8, the one that traveled the farthest is going to have the greatest difference between pH and PI? Well, this one is at 4 right here. Trial 8 has a pH of 4. What's this guy that traveled the farthest? It's going to have the farthest pH from 4. What are my options? Aspartic acid, lysine, arginine. What's the furthest from 4? Arginine, 12. Answer option J. And last one, in experiment 2. No, not the last one, 2 left. Experiment 2. Trial 6 and trial 7 differed in which of the following ways? Okay. More amino acids, more acidic, more acidic. All right, one of those is wrong straight off. So 6 and 7. Notice that 6 and 7 have the same pH. If they've got the same pH, well, then one can't be more acidic than the other. So we can cross out answer options C and D. A quick aside, if you don't know about the pH scale, in the middle is 7, that is neutral. Down low here is 0, that is acidic. Up here is 14, that is basic. And that's just about as much that you need to know regarding pH to be successful on the ACT. More amino acids or fewer amino acids? Well, which one had more amino acids? 6 has 1, 2, 3. 7 has 2. I can count dots. 6 has more. 6 has more. That's going to be answer option A. We can count dots. And 1, 2, 3, 4, 5, 6. Oh, we got 7 here. Got a 7th one. Now let's pull out what color? Terrible yellow. Suppose paper electrophoresis is performed on 2 amino acids. Amino acid 1, which is a pi of X. Amino acid 2, which is a pi of Y. If the solution used has a pH of Z, under which of the conditions would each amino acid have a net negative charge? And then I look up here, net charge. You would say, how do I know about net charges? You wouldn't. But if you looked up for that word net charge, you found a negative sign there. And you said pH has got to be greater than PI. So if the pHs are greater than the PIs, well, what's the pH? The pH is Z. Z's got to be greater than some combination of X and Y. Which has that? Only one of them. Answer option J. So if you didn't know what to do, a great thing to search for there would have been net negative charge. You said, what do I know about net negative charges? Move on to the next one. If I can find my mouse. All right, you've got two more passages in the practice packet, but we're not going to do both of them. We are only going to do passage 5, passage 6, dealing with antiseptics. I think these are antiseptics. No, hydrolysis. Check that, hydrolysis. I got another one, looks like this, antiseptics. So this is about hydrolysis. We're not going to do that one. You can come back to it if you want. We're going to do passage 5, which has got these nice data tables. What are we doing? We're firing a bullet into a block and seeing what happens. So let's walk through this one. But you first, pause it. Pause. And give yourself like a 7-minute timer. And say, can I do these at the pace that Mr. Kraviec expects me to do them? Do I have to get them all right? No, but like 5 or 6 of them? Oh boy, would I be excited if you got 5 or 6 of them right. So let's jump into it. Number 27. Very nice. Gives us a vocabulary word. How do I know it's in italics? A controlled variable is held constant. And what does constant mean? It means it is kept the same. What were the 3 controlled variables for trials 4 through 6? So we look at trials 4 through 6 and say, what was the same? Well, very clearly MP was the same. So I can go back here and find which answers have MP in them, which don't. C and D aren't possible. And then I see what else is controlled. That might say, oh, let's look at the study. Various combinations of MP and V were tested. Well, MB equaled 2 and K equaled 3. Those were kept the same. MB equaled 2 and K equals 3. It's going to be answer option A. How else could you have found that? You could have noticed that X varied throughout, X varied throughout the study. Number 28, we got an assume. Assume each projectile and each block could be tested once. How many pairs had been tested? 12. I don't really have like a secret key for you there. There were 12 different trials. If we did 12, if we can only use it once, we must have had 12 of them. Was the momentum, and you may have forgot about what momentum is. That is speed times mass, or mass times speed, product of the speed and the mass. Was the momentum of the projectile in trial 3 before impact the same as in trial 1 before impact? Well, and it's going to have to do with either velocities or masses. So let's take a look. Trials 1 and 3. If I look at trials 1 and 3, what do I see? They have different masses, same velocities. Different masses, same velocities, different masses. Answer option B. 3 down, 4 to go. Number 30, based on the results of study 1, which of the following graphs best represents the relationship between KE and V? Well, let's take a look. KE goes up. Oh, excuse me. KE and V, there we go. So as KE goes up, V goes up, right? V goes up, KE goes up, great. Up here, V was kept constant, so we don't really see what happens. But as the velocity goes up, the kinetic energy goes up. But all right, so it's going to be one of the goes up ones. How do I tell the difference between these goes up ones? This is like constant rate. And this is kind of exponential or quadratic looking. What do I see here? Well, this goes up 125, 625, 870. Oh man, that's like speeding up. It's getting faster. So that's going to be G on that one. That's a quadratic curve. If you wanted to know, the equation for kinetic energy is 1/2 mv squared. Those of you who've taken physics know, oh, that's quadratic. That's quadratic. Cool. 3 to go. And then you guys will get a chance to work on your own. Number 31. Prior to impact, if you don't know what the word prior means, that means before. Before impact, mechanical energy is KE. So I'm going to say before all right, mechanical equals KE. After impact, mechanical energy equals PE. Cool. Based on the results of the study, did the system more likely gain or lose mechanical energy? All right, so did KE go, did this go up or down? All right, so looking at KE and PE, KE is always greater than PE. It's always going down. Look at these. KE is big, PE is small. It's always going down. So was it gained or lost? It had to have been lost. In any trial, KE was greater than PE. KE was indeed greater than PE, but it didn't gain, lost energy. 2 left for you. Number 32. Based on the results of studies 1 and 2, suggests I might need to combine some things. Which of the following combinations of M, P, V, MB, and K would yield the greatest value of X? So I'm going to try and maximize. So I'm going to look first and say, okay, which one should I pick? Should I pick these two or these two? What's going to make the greatest value of x? And I look over here and I say, oh, if I compare 0.1 to 0.3, ah, 0.3 has a bigger x. So I know I'm going to want 0.3. So it's not going to be the 0.1. So I can cross out f and g. All right, and now is it going to be a 5 or 20? Which one's going to give me a greater x? All right, 5 gives me 0.2. 20, 0.8. So I'm also going to want higher v. So it's going to be cross out 5. We're going to have answer option J. So, you know, go 2 at a time. Let's say, what's it going to be first? Okay, MP makes it bigger. What else makes it bigger? V. Last question's got a question dealing with kind of independent and dependent variables, mathematical relationships to best determine the mathematical relationship.
If a grade is missing, be certain that you...
Doc had to let us teachers know how to put our grades in the grade book there. To best determine the mathematical relationship between k and x, the data from which trials should be considered. If we want to know the relationship between k and x, well, we should change k, right? Change k to see how x responds. So where is k changed? K only shows up down here in table 2. I see here it was changed. That's going to be trials 10 through 12 because k was the independent variable in those trials. The independent variable is the thing that is changed. So there you go. You've got one more passage in here dealing with hydrolysis. You can do it or not if you want. Give me one moment. All right, looking at the group work for today, group work number 3. Let's flip through this real quick, look at a few things of interest. First one, we've got some, what are we doing? Oh, the tiny aquatic crustaceans, fun times. We've got some nice tables. You got to read some procedures on this one. You got to read those steps very carefully. This one is thinking about filters. People struggle with the idea of filters. What do you filter out first? You filter out the big pieces first or the small pieces first? How do you pan for gold? I don't know. Think about that. So 3 passages for group work number 3. Get those in. That's all I've got for you today.